Hi everybody. In this video, we're going to look at the harmonic identities. And this is where we can write an expression involving cos and sine as a single cos or sine function. This is really useful when you want to find the maximum or the minimum. So for question 1, we've been asked to prove that this left-hand side is identical to this right-hand side. So we'll begin with the identity for this left-hand side. This will be cos of alpha plus beta. We can see that the alpha will be theta and the beta will be the alpha term. Okay? So we'll have r multiplied by the cos of theta times the cos of alpha minus the sine of theta times the sine of alpha. Now we can expand out this bracket. So we've got r cos theta cos alpha minus r sine theta sine alpha. And now we need to match up the terms. You can see on this term, we've got a cos theta, and we have a cos theta here. So this A must be the r cos alpha for them to match up. So we'll say that r cos alpha must equal the A term. What do you think this B term will equal? So the sine theta will match up with this sine theta. So the B term must be the r sine alpha term, okay? Now to write r in terms of A and B, we can use the Pythagorean identity. And this is where cos squared alpha plus sine squared alpha will equal 1. So if we make cos alpha the subject, this will be A over r squared. If we make sine alpha the subject, this will be B over r squared. Together they'll add to make the 1. So now we have A squared over r squared plus B squared over r squared will equal 1. So we have a common denominator. We can move the r squared over to the right-hand side. So we'll have a squared plus b squared will equal r squared. We'll take the square root of both sides. So r will equal the square root of a squared plus b squared. You don't need to go through this derivation every time. You can just remember this formula, but it's really helpful to understand where it comes from. To work out alpha, well, we know tan alpha would be the sine over alpha divided by cos alpha. And we know sine alpha, this will be b divided by r. And we know cos alpha, this will be a divided by r. So if we multiply numerator and denominator by r, then these will cancel. So the tan alpha will be b over a. So alpha will be the arctan of b over a. So in example 2, we're going to look at how we can apply this. We've been asked to express the root of 3 sine theta minus cos theta in the form of r sine theta minus alpha. Do you want to give this question a go yourself? Okay, so welcome back if you had a go. We'll begin with expanding this out. We'll have r multiplied by the sine of theta cos of alpha minus the sine of alpha cos of theta. And now we'll expand out this bracket. So we've got r sine theta cos alpha minus r sine alpha cos theta. Now we'll match up the terms. We've got sine theta and sine theta. So the root 3 must be r cos alpha. And then we've got negative cos theta, or negative 1 times cos theta. So r sine alpha must equal that 1. So to work out r, this will be the square root of root 3 squared plus the 1 squared. This will give us a square root of 4, which is 2. And then to work out alpha, this will be sine alpha, which is 1, over the cos of alpha, which is root 3. We'll take the arctan of both sides, so alpha is pi over 6. So root 3 sine theta minus cos theta is identical to 2 sine theta minus pi over 6. Okay? And then for part B, say the maximum and the minimum values. Well, the maximum, if we consider the sine of any angle, the maximum that can possibly be is 1. So the maximum this right-hand side could be is 2 times 1, which is 2. So the maximum is 2. The minimum, well, the minimum this could be is negative 1. So this would be 2 times negative 1. The minimum would be negative 2. And it's worth knowing for what value of theta would it be at its maximum. Well, its maximum is at pi over 2. So when theta minus pi over 6 equals pi over 2, you'll have a maximum. And this will be when theta equals 2 pi over 3. To find the minimum, well, this is when theta minus pi over 6 will equal 3 pi over 2. So now theta will be 5 pi over 3. Okay? Let's try one more question. Okay, so finally, we've been asked to express 8 sine theta minus 6 cos theta in this form, and then to use that to solve this equation. So if you want to give this question a go yourself, you can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So if we expand this out, we'll get r sine theta cos alpha minus r sine alpha cos theta. So the r cos alpha term will be the 8, and the r sine alpha term will be the 6. So the tan of alpha will be sine over cos. We'll take the arctan of both sides. So alpha works out as approximately 36.9 degrees. R will be the square root of the 8 squared plus the 6 squared. So this will be root of 100, this will be 10. So 8 sine theta minus 6 cos theta is identical to 10 sine theta minus 36.9. To solve this equation, well, we've just worked out a simpler version of this, so we can substitute what we've just worked out into this left-hand side. So 10 sine theta minus 36.9 will be equal to 7. We'll divide both sides by the 10. This will give us 0.7, or 7/10. Then we'll take the arc sine of both sides, and we'll get approximately 44.4 degrees. And now we need to adjust our range. We'll take away the 36.9 from both sides. And this will be less than or equal to 323.1. So to work out where the solutions are, we'll draw the CAS diagram. We know the 0.7 is positive, so we're looking at the first quadrant and the second quadrant. So theta minus 36.9 will have solutions at 44.4 and 180 minus the 44.4, so 135.6. To work out theta, we need to add the 36.9 to both sides. We get 81.3 and 172.5. Okay, well, thank you very much for watching. I hope you found that useful. If you want more practice on this, you can download the worksheet and the online lesson from my website, mrmathematics.com. I'll leave a link to that in the description below.